Welcome to section 0.3, quadratic functions and equations. Today's objectives are to graph quadratic functions and to solve quadratic functions. So solving quadratic equations or functions, we have four methods you have learned. We have graphing, we have factoring, completing the square, and the quadratic formula. We're going to review each of these today. Here we have graphing a quadratic by hand. So consider the quadratic function y equals x squared plus 2x plus 2. So to graph by hand, we want to be able to find the axis of symmetry. And if you recall the axis of symmetry, we find the x coordinate and the AOS by x equals negative b over 2a. In this case, our b is 2. This is equal to negative 2 over 2, and our a is 1. This is negative 2 over 2, which is negative 1. So my AOS is x equals negative 1. To find a vertex, we're going to plug the negative 1 back in to find our y coordinate. So y equals negative 1 in parentheses squared plus 2 times negative 1 plus 2. When you do this, negative 1 squared is 1. 1 plus 2 is 3. You have 2 times negative 1, which is negative 2. Add it all together, you get that this is 1. So my vertex is the point negative 1, 1. And the vertex is written as a point. It is an ordered pair. So I have this table here I'm going to use to help me solve this. To graph it, I'm going to put my vertex in the middle, negative 1, 1. And then for step 3, find two other points and reflect them across the AOS. So we want to use nice numbers since our vertex is right here on my graph. I'm going to use nice numbers, and going toward the y-axis is really nice because we can use the y-intercept. If we go that way, we're going to go to 0 next, and our y-intercept is just 2, that plus 2 at the end. So we're at 0, 2 right here. When we mirror that across the axis of symmetry, we go 1 to the left of the axis of symmetry. That will be at negative 2. We'll also go to 2. Now I need to find my other points yet. Oh, we're going to put that in there first. There's negative 2, 2. Now we're going to go to x equals 1 and solve when x is 1 to find our y coordinate. So we have 1 squared plus 2 times 1 plus 2. And when you do this, you get 5. So 1 goes to 5, which is right here. That means that negative 3 also goes to 5 because we're mirroring it, which is right here. And then in step 4, we could connect with a smooth curve. There's my smooth curve. Make sure you put your arrows on the ends. We want to know if this thing opens up or opens down. You can find that by this leading term. The leading term, if it's positive, means it opens up. If the leading term is negative, with a coefficient like negative 2, it would open down. Question 6 asks, is the vertex a maximum or a minimum? When we are opening up, the vertex is at the lowest part of our graph, so it is a minimum. If our parabola opened down, our vertex is at the top of the graph, and it's called a maximum. So we know it is a minimum, and it says, what is the maximum or minimum values? We're looking for the minimum value. There are two ways to write this. One is just use the y-coordinate from our vertex, and it's just 1. Sometimes you'll also see it written as an ordered pair where the vertex is. I've seen both used. This is what I usually see in calculus. When it asks for the value, it just wants the y value. I will take either for this course. For your domain and range, unless there's restrictions, your domain for a parabola is all real numbers. The range, since we are opening up, all my y values are above or equal to the vertex. So y is greater than or equal to the y coordinate of the vertex. And again, if we were opening down, it'd be y less than or equal to, but we are opening up, so all my y values are greater. All right, that is graphing a quadratic by hand. This is something you should be able to do. All right, so now we're going to solve by factoring. There's two ways you've learned. One is when the leading coefficient is 1. So here we have x squared minus 10x plus 21. When we factor this, the only way to get x squared back is to actually have x times x. Now we want to do is see what multiplies to 21 that adds to the middle term, negative 10. And if you look at 21, the factors that will multiply to 21 and add to negative 10 are negative 3 and negative 7. That's my factored form. And then what you do is use the zero product property. X minus 3 equals 0. X minus 7 is 0. And my two solutions are 3 and 7. Those are my solutions for solving by factoring. So the next one, we're going to also solve by factoring. We need to move the 5 over first. So we have 4r squared minus r minus 5 equals 0. The way you learned how to do this in the past is you do AC split. You multiply the a and the c together. AC in this case is negative 20. We're then going to find out how we can split to get the middle term. This is what we're going to do next. So what multiplies to negative 20 that will add to negative 1? Well, negative 5 and 4. So now we split the middle. 4r squared minus 5r plus 4r minus 5 equals 0. We group the first and last terms together. We factor out our greatest common factor. We have r. This is 4r minus 5. All we can take out of the next group is a 1. Leaves 4r minus 5. From here, so we have 4r minus 5 as a factor, and r plus 1 is a factor. We set them both equal to 0, and r plus 1 equals 0. We solve both, and we get r is 5 over 4. And r is negative 1. Those are my two solutions. All right, that is solving by factoring. The next thing we do is completing the square. To complete the square, the leading coefficient must be 1. So if you have a coefficient other than 1, you must divide the equation by that first. We need to find a c value that will make our trinomial on the left into a perfect square trinomial. To do this, we take the b and divide it by 2, and then we're going to square that result. For this equation, our b is negative 4. This becomes negative 4 divided by 2, all squared, which is negative 2 squared, which is 4. We need to move the 1 over first to make room for our new c value. So now we have x squared minus 4x plus 4 equals negative 1. And we have to add the 4 to that side as well. So we find this new c value, we add it to both sides. We get 4 on each side. On the left, we have a perfect square trinomial. And what you do is you take this number before you square it. Half of b is what goes inside the binomial. We take negative 1 plus 4, we get 3. We now have a squared term, x minus 2, all squared, equal to 3. We use the square root property. Take square root of both sides. And we get x minus 2 equals plus or minus square root of 3. Add 2 to both sides. And we get x equals 2 plus or minus the square root of 3. And that is my solution. That is completing the square. One thing you guys probably don't recognize, but if we took this form and changed it a little bit, this completing the square is used for more than just finding solutions. We bring the 3 back over and make this equal to 0 or equal to y, or f of x. This here is vertex form. We can pull the vertex right out of this equation. And this vertex for this one would be your x is positive 2, your y is negative 3. That is where this thing is. The vertex is at 2, negative 3. That is one of the reasons why we learned completing the square, because it puts us in vertex form. We can find the vertex of the equation rather quickly. All right, and then the last one, quadratic formula. You guys hopefully remember the song. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Should hopefully bring back some memories from intermediate when you had me, for those that had me before. Make sure your quadratic is set up equal to 0 or f of x equals type equation. And then we're just going to plug things in. So x equals the opposite of negative 4 is 4 plus or minus the square root of b squared. So negative 4 squared minus 4 times the a times the c all over 2 times 1. And then we go around and simplifying things. 4 plus or minus. We have 16 is negative 4 squared is 16. 16 minus 60, we get negative 44 all over 2. We are going to simplify our radical. We've done complex numbers. We have a negative 44, so we're going to pull out an I, because this would be like negative 1 times 44. We're going to pull out an I, and a perfect square that divides into 44 is 4. Because we could have this as 4 times 11. So we can pull out the square root of 4, which is 2. We pull out an I, square root of 11, all over 2. And this one we do have to simplify because every term in the numerator is divisible by 2. So we can make this into 2 plus or minus I, square root 11. And that is my solution for this quadratic. That is all for solving quadratics, graphing, factoring, completing the square, and the quadratic formula. Thank you for watching, and have a nice day.